7.5, graphing quadratics in vertex form, vertex. So this is the first time we see graphing with these quadratics, if I remember right anyways. And so it's a bundle of fun, or joy, I guess, whatever. When graphing quadratics in vertex form, sometimes it's necessary to complete the square, which is, I don't know, to me it's kind of nice. Not to most people, but to me. Now, yeah, well, I could be. Now, when you're graphing, there's, well, let's get to the next slide. In these graphs, the blue line right here, there's lots of lines. This is kind of cluttered, but the blue line would be the actual graph of these quadratics. Quadratics make what we call a parabola, which is what this is. I forget what the Greek, means from para. I thought was many, and bolas is, I don't know, I think of Ebola, but either way, it's kind of like this way, it's a smiley face, but sometimes they can go downwards like this as well. Now, so there's some vocabulary that should be familiar already, such as a y-intercept. So wherever this line goes through the y-axis, they didn't put that right there, but it's a y-axis right there. That's a y-intercept. And any values that go through the x-axis are x-intercepts. Now, it says right here that they're solutions. That's because when you solve these, when they're equal to 0, it's saying that it's equal to 0, the y is equal to 0, which means you're solving for these x-intercepts, also known as roots, if you care. Now, the vertex is the very peak of the parabola. Like this vertex right here, look, it appears to be at 1, -4, okay? But you'll notice, if you did notice, this dashed line right here, they call it the axis of symmetry because parabolas are symmetric, meaning whatever happens on one side of the axis of symmetry happens on the other side, just reflected, okay? So it kind of just reflects itself over this axis of symmetry. And sometimes what I'll see is that students, they just kind of graph half of this line, and then they'll just kind of reflect it over, right? Like, here's what I mean by reflect. So if no, well, I'm used to speaking in this math nerd way, but yes, mirroring is a better way, is a more common way to say it. It mirrors itself. So here's what I mean by that is you see this point right here that's at -1, 0. It reflects itself over the axis of symmetry, meaning from the axis of symmetry, it's 2 to the left, and its reflection or mirroring is 2 to the right. Same with this one right here. See that? It's 1 to the left, so its reflection is 1 to the right. And this would be true for any of these points, meaning if, I wouldn't use this one because it's fractional, but you can see right here it's 2 and some change to the left, so from the axis of symmetry, so its reflection is 2 and some change to the right. It reflects. And so that's the nice thing about graphing these, is that you can kind of just do half of it and then just reflect it if you want. I like that. Like our absolute values were kind of a straight line, then it gets to a tip and then it reflects backwards this way. Yeah, that's exactly right. It's just now it's curved. Is that pretty? I don't know. But these vocabulary right here, vertex, axis of symmetry, I don't remember seeing x-intercepts and y-intercepts on the assignment so much. Maybe y-intercept, but the x-intercepts, we've been doing those pretty much the whole time that we've been solving equations of quadratics, like that last section that we did, in addition to others. Now the vertex is crucial because this is the point where the axis of symmetry goes through. What they're going to ask is, we want a equation for the axis of symmetry. The axis of symmetry, see, it's just a straight vertical line. Vertical lines have the equation format of x equals whatever the x value is. So this is where you look at the vertex, because it will always go through the vertex. See how this one is x is 1? So the axis of symmetry equation is x equals 1. So don't overcomplicate that. Just once you get your vertex, which is usually what you would do first, then look at the x value. The axis of symmetry is x equals that value. That's the equation for that line. They've dashed it, but I guess suppose you don't have to if you were to graph it. I don't remember having to graph it, but you have to identify them at least. For the parabola graphed below, identify its vertex. axis of symmetry and state if it opens upwards or downwards. So unlike the example that we saw on the last slide, this one is, well, I guess I'm starting with which way it opens. But I can see that it's opening downwards, right? So this would be a down. I'm just going to put downwards. That's fine. Now, how do we know if it goes up or down? Well, I mean, hopefully that kind of makes sense. But the lines in the end, they would continue downward if it opens down. That's one way to think about it. Or you could say it's pointing up, so it's opening the opposite direction. Whatever works for you. The vertex is the tip of this thing, which it appears to be right here. And that ordered pair, from what I can tell, is the x value is -4 and the y value is 2. Now, noticing that vertex, if they give you a graph, is crucial when you're writing the equation because it will help. I don't think we have to write equations today, but you could. Okay, now the axis of symmetry, as usual, is always going to be x equals, and then I just look at my vertex x value, which is -4, and I say x equals -4. That is my axis of symmetry, which if we were to draw, would be, let's pretend like I drew that really well, even though I use electronics, but this line, again, it reflects all of these values on this parabola. This curve, this line, mirror over this axis of symmetry. Okay, for this one, we got y equals ax squared plus bx plus c. This is standard form for a quadratic. And if the a is positive, then the parabola will open upward. So a parabola is just like a smiley face or a frowning face. If it's positive, if a is positive, then it's going to be a smiley face. It opens upwards because it would continue upwards in both directions. If that a is negative, then it's going to open downwards like this. So again, it would be that both ends of that parabola are going to go downwards. Now this creates an interesting situation for us because the steepness of the y-intercept will depend on where this either one of these parabolas, where it falls on the y-axis. Because, for example, is let's say that I have a smiley face like this. If my y-axis is somewhere to the left of the vertex, let's put the vertex right there, then we can see that this line is going downwards, right? Downwards, 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 which would make the steepness at the y-intercept a negative. Okay, so if that happens, it's negative. If by chance we had the same parabola, but now the y-axis is on the right side, now you can see that it's on the right side of that vertex. So it's going to go up, up, upwards, and so this would then make it positive. The same idea is true for our frowny face parabola. So if it was down like this one, and if the vertex was at the tip there, then the x-axis, the y-axis rather, is right here. Again, you can see that this is going upwards, upwards, upwards as you get to the y-intercept. And so that would make the y-intercept positive, the slope positive at the y-intercept. And if by chance we had the same or a similar parabola, the frowny face, again, if that's my vertex, then anything to the right there, now I can see it's going down, 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 which would make that a negative right there. So you got to be careful, think about which it is, because whichever one it is crucial there. Remember, it's going to depend on where your vertex is and which side of the line it's on, and then also if it's going down or up, down and then up and then down, up and down. But you notice right here, like when we look at the a value, we're just looking at which direction the arrows are going. For here, we have to determine which direction it's going from left to right. So that's also pretty important right there. This is a left to right basis. Now the last part here, the y-intercept and shifts the graph up or down. Really, you're just looking at the c value because at your y-intercept, your x is always going to be 0, and you just find your corresponding y-intercept. For these particular problems, it is the c value. So if the c value here is positive, then you know that that it's going to be a positive y-intercept. If it's negative, it will make it a negative y-intercept. Okay, and that would be true if you were to look on a graph, for example, something like this one. Let's say it's a smiley face. Again, you'd look at the y-intercept, which is where the line goes through the y-axis, and again, the x value is always 0, but right here I can tell whatever the y value is, it's going to be negative, which then we would say the c value is going to be a negative. Now, the last thing I need to mention here, because remember, on these four scenarios for the y-intercept, here with these ones, we went to the left and then to the right. If it's a smiley face parabola, if it's a frowny face parabola, then we went to the left and right there. But what if the y-intercept is actually the vertex? Okay, so let's say that I had a smiley face one rather. And again, this is my vertex right there. But let's say that my y-axis is going straight through there. If that's the case, then it's right at the tip of that, meaning it's not really going down and it's not going up. It's just straight flat right there, and in this case, it would be 0. Not at 0, it's not at 0. I'm just showing that the slope there is 0 because it's right at the tip. It's where it changes from going, in this case, downwards to upwards. And it has to change at 0. So if your vertex is the y-intercept, then you have a b value that is 0. So this problem will demonstrate that perfectly for us. Okay, now the first thing here, let's do the value of a is, well, this one's opening up downwards. So since it's going downward, then I know that my a has to be a negative. Okay, well, what about the b? This one is where my b, again, I'm concerned with the y-intercept, which is here. That is at 0, -1. And since that is also the vertex on this problem, the y-intercept equals the vertex. Then I know that b would have to be 0. If it were anywhere else, then I would have to consider, okay, where is my y-axis in relationship to this? Like, again, if my y-axis were right here, if it were this line, then I would say that my b would have to be positive because it's going upwards right there. Let's say that the y-axis was this line, then it would be going down right here as well. Last thing I got to do right here is to figure out the value of the c. Is it positive, 0, or negative? If it were 0, then it would have to be right at the origin. But right here, I can see it's below the origin, meaning that, well, you see right here that the y-intercept is showing a negative y value, which means that the c value is also negative. Okay, so we're just going to make up our own right here, and I'm going to do my best to draw a parabola, which you've seen kind of sucks, but I'm going to try my best. All right, there we go. I got my parabola. And so, again, this one right here, the a value just is asking, really, does it open up or down? And I can see this one is going upwards on both ends, so this would have to be positive for my a value. Now, for the b value, we do need to consider the y-intercept. Now, the y-intercept right here, it is right there. I don't really care about the ordered pair, but what I see is that remember, the vertex is right at the tip of my parabola. And what's happening to that line at the vertex? Well, since this is always going from left to right, you'd have to say it's going down, 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 down. Since it's going downwards at that y-intercept, as it turns out, this one is going to be a negative. The b will have to be negative there. The next part there, the value of c is, well, the c is the actual y-intercept, which is here. We already found it. But the x is 0. Right here, though, I can see that this y-intercept is above the origin, and so I know it's going to be a positive. I don't know what number it is, and that doesn't really matter because I don't really care what it is. It's just that it's positive, and therefore my c value would be also positive. Okay, because remember, if x is 0, it really zeroes out these two terms, and you're just left with this number. Since this value is positive, the c would also have to be positive. All right, graphing the parabola defined by this. f of x equals a times the quantity x minus h all to the power of 2 plus k. This is what we call vertex form. I feel like there should have been fireworks after that. In any case, the parabola has the same shape as y equals x squared, which is just, like we saw in that last one, it can be up or it could be down. Smiley face, frowny face, however you want to put that. But the good news for us is that when it's in this format, you see here we've got h and k in this expression. Those would be numbers. And those numbers represent the vertex, which is what this is saying right here. It takes on the ordered pair h, k. Now, it does need to be minus, so if I saw a plus right there, I would know that I'm really subtracting a negative. And if this was a minus k right there, then I would know that the k is negative as well. But if it's in this format, at the very least, they're telling us not only where the vertex is, or if we can switch it into this format, it forces us to see the vertex, which you will need when graphing these on the assignment, but it also tells us where the axis of symmetry is, which, again, if we're doing this by hand, like I'm going to be doing, it should help. And then you see right here that the axis of symmetry, it's x equals h right there. That's because you just, remember the vertex, you take the x value, and that's the equation is x equals whatever that x value is in the vertex. Now the same thing though, like we saw on the last couple slides, if it's in standard form, the a value, if it's positive, the parabola is going to open up, which would be the smiley face. If the a is negative, the parabola will be opening downwards. So a frowny face, like maybe that second try wasn't as, well, it's probably about as good as that first one. Now, the rest of this isn't really important for right now, other than, I mean, if you wanted to like go on to some kind of online graphing calculator and be like, I'm gonna mess around with these equations and I'm gonna take h and I'm gonna move it to the left, I'm gonna make it negative, I'm gonna make it positive and see what happens, you can. It's a decent activity if you're actually trying to understand this, but if you're trying to just get through class, this is good enough. The k as well, as this goes up, then it usually shifts the graph up. If it's negative, it usually goes down. And then again, a will also depend on the contraction or expansion, meaning if a can make it thin like this one, but it could also make it kind of wide like that. These last three aren't so important because technically speaking, I mean, if it's in this format, you have the vertex, but you can always just use x and y. You can choose your own x values, plug it in, and then see what y value comes out. So the old-fashioned way of graphing, which usually we showed with a table, so you know, something like this. Remember, said you got an x and y's, and then you chose your own x's and y, and then you found the corresponding y values, right? So you can say, well, x is -2, -1, 0. This goes back to like 990 stuff, or even 920. But again, I'm just choosing those values, then I just replace the x's in this equation with these x values that I've chosen and find the corresponding y value. If I know where the vertex is, I really only have to go one direction, and then I can just reflect it, which may not make sense right now, but hopefully it will. This one, we're not asking you to graph. Just can you tell where the vertex is and which way does it open? Let's start with the vertex because the format, let's see if I can write this in, should look something like this, okay? So let's just, again, just working on the vertex right here, h and k. So this is x minus 7. Remember, it's x minus, so if it's minus already, we just take the 7 there as our x value. So it's a positive 7 right there. Okay, but here next I see it's minus 5. And so plus k, this could be like plus -5. And that's important too because then the corresponding y value is -5. So this is our vertex. It didn't ask for it, but the equation for the axis of symmetry would be x equals 7. Because now that we have the vertex, that axis of symmetry equation, very easy to obtain. But then it says, well, which way does it open? Well, that depends on the a value, but it's not showing one. So you got to be careful. Hopefully by this time we understand that there is one there. No pun intended. You just can't see it. Yeah, it's 1. So, and that 1, by the way, is positive. So since it's a positive 1 right there, a is positive 1, that means that this one is going to open upward. it opens upward. Upwards? Whatever. Now the question is, now that we have a vertex, could you actually put that vertex on a graph? And I hope you could, because just graphing an ordered pair at that point. Now, is that the only ordered pair you need? Of course not. But we need at least this one so we can find where the tip of that parabola is. Now on this graph, which now we're graphing, we do need the vertex. In fact, on the assignment, you're going to need only 2 points to graph. You're going to need a vertex, and then any other point will do. How you find that point is completely up to you, but you get to decide, okay? So for this one, I'm going to limit the number of methods that I'm going to show how to find other points, but the vertex is shown already because this has the vertex format for our parabolas, for the quadratics, which is, okay, so again, it's in vertex format. That's it's helpful because now I can tell where my vertex is. And the h, see how it's a plus 3, but it should be minus, right? Which means it's really minus -3. So my x value for my vertex is -3. And then whatever this is, just this number right here with the k, just whatever operation is to its left is its sign. So this one is -5. So we end up with -3, -5, which on my graph is right here. And that's my vertex. Now before I label that, I can see the a value is positive. So I'm expecting this to open upwards, something like this, okay? Something like it. I don't know that it will, but I know now that I can label this -3, -5. I say that because I didn't want to put it right here where it's going to be in the way of the graph. So I know it's going to open upwards, but again, on the assignment, all I need is one other point. And yeah, we know that the axis of symmetry would be x equals -3. Let me see if I can put that in here. There we go. The orange right there is my axis of symmetry, which means, again, all the points that I put on the graph are just going to reflect over that line. They're going to mirror over that line. I like mirroring there. But what I need then is some kind of values to put in to my graph. And what I said before is you only have to go one way, and that's usually what students do, and then they just reflect them. So it doesn't matter if you go to the right or to the left. Any values that I get on either the left or right, I can just reflect back, which I will show you here in a second. What I know is that I can't use -3 for my x because we already know its corresponding y value. We already have that ordered pair. If you were to put -3 into the equation, the original up here, then you would get a y value that's -5. Okay, so again, that's an ordered pair. That's what a table is going to give us. But we need other ordered pairs. So it doesn't matter which way. I'm going to go to the right, by the way. So I'm going to make x -2. Now, you can say, well, we're going to use the equation right here, right? So y equals 2 parentheses x plus 3 squared minus 5, and then you replace the x with -2. I'm really just putting this in the calculator, you guys. So to -3, right? So I get -3 right there. Now on the assignment, that's enough, right? So I got -2, -3, which would be right here. Okay, so that's at -2, -3. But since I'm doing this by hand and I'm enjoying myself probably more than I should, I'm going to put more. And I know you want it too. So I'm just going to go up 1. So I'm going to make this -1. And instead of showing the work here, just because hopefully we're used to this by now, I'm just going to put it in the calculator, okay? So I'm just using the storage function of the calculator so I don't have to type in 2 parentheses x plus 3 parentheses squared minus 5 all the time. But I got a +3 on that, yeah, 3. So again, that's an ordered pair, -1, 3, which is up here, like this. Now I'm going to go one more. I'm going to make x equals 0, and then I see what I get. So 0 store for x. And just go up here and copy this in. Yeah, it's 13. Now 13 is not on my graph. I know that it's somewhere in this range, but that gives me a good view of what's happening with my equation here. So remember what I said. I'm only doing half of the graph because if I'm doing this by hand, I can just reflect these points. So from my axis of symmetry right there, this purple point is one to the right, so its mirroring would be 1 to the left. It'd be this point right here at 4, negative 3. Now this also means that if you were to replace the x up here with negative 4, you would get a corresponding y value that's negative 3. And then this next one as well, that's 2 to the right, so I go 2 to the left, and that's my next point right there, which appears to be at negative 5, 3. Okay, and I guess I don't really need that other one. All right. Now I must graph this. Apologies in advance. Oh yeah, that was, in my mind, that was so perfect. So I would accept something like this on an exam, which other math nerds wouldn't like, by the way, so don't tell anyone. But here's what we don't want to see. Let's see if I can, something that looks like, it's like, look, we don't want you to drink before class or during class, because but if you, yeah, like maybe you're on medication or something like that. Okay, just yeah, please. I mean, look, if this one's pretty bad right there, right? Most students like, Sal, how can you suck at drawing parabolas that bad? I did my best, okay? If it was on paper, by the way, and I know you haven't seen it, but I feel a lot better about my drawings. This is just because it's on an iPad. It's jacked up. Yeah. I know, right? So, in any case, I don't want to see any garbage like this ever, because this is like, hey, Sal, watch what I'm going to do. And it's like you're just testing me, which I really don't mind so much, but other math nerds do. So let's get rid of that garbage. There we go. Okay. So here's another thing that sometimes I'll do is I'll kind of do it one point at a time, right? So I just kind of connect these. I just go up here like this. Again, that's okay. And if you want to be really thorough, you just put some arrows on the end there, and that's pretty.
Have the arrows on it?
Yeah, the pattern does continue, so you should put arrows there. Now, again, on the assignment, if you start with the vertex, you put this point on there. I have 4 other points to choose from this graph. As long as you put one of those other points on there, the assignment will graph the rest for you. But when doing it by hand, you're going to have to, do it by hand, so you need more than 2 points. So there's our vertex format. And again, if this did not come in its vertex format, we would have to use completing the square, which we haven't done yet, but I assume we will eventually. What I have here is my vertex to start with, and that's good because we need the vertex when we graph these on the assignment. Also for graphing by hand. So I can see that the h is just a regular 5. Again, the minus sign doesn't really go with it. It's just part of the format. And then the k here is positive 3. We know that because it's a plus 3. So let me get that on the graph. At 5, 3, which would be, for me, right here. Now, I'm trying to be careful with where I put my labels, right? 5, 3, I'm putting it up here because I know this one opens downwards. How can you know that already? It's because this is a negative a right there in front. In fact, it's a negative 1, which tells us, the a value being negative tells us it's going to open downwards. Okay, well, that's fine. But I still need some other points. Oh, I just put my vertex down here, right? Also, my axis of symmetry is always x equals whatever the x value is in the vertex. You could say h, but it's 5, yeah. So let me see if I can get that on the graph as well. That's decent. It's pretty good.
And that would have an arrow at both ends.
All right. Well, I'm going to use a calculator to find my x and y values. Now, I'm going to make my table. So I got my x and y's. I'm going to set this up for several values. 4, I guess. And again, I only need to do one sided line. Doesn't matter if I go to the left or the right. I tend to just kind of drift towards wherever 0 is, and that means for me it's to the left, and then just reflect, because 0 is a very easy number to work with. Will I get to 0? Probably not. And that's okay that I won't. But I'm just going to go to the left, so I'm going to go downwards in my x's. So I'm going to go 4, and then 3, then 2, then 1. Let's see how far that gets us. But again, I'm just plugging this into the calculator. So I'm going to say in my calculator first, store for x. So I got x, 4 stored for x, then I type in my equation. Negative, parentheses, x minus 5, close parentheses, to the power of 2 plus 3, enter, boom. Yeah, it's 2. So 4, 2 would be 4, 2 right here. Okay, so let's do 3. So I say 3, store for x, enter. I go back up to my equation, press enter, enter, and it says your x, or your y value rather, is -1. So that'd be 3, -1 here. Okay, let's try 2. 2, store for x, enter. I go up back to my equation with the x, I push enter, and I get -6. 2, -6, which is down here. That means 1 isn't going to make it. I still want to see what it is though. So 1, store for x, I go back up, push enter. Now if you don't have the storage thing down, that's okay, but I get -13. So that would be, you know, somewhere down here. I'm not going to label it because it's not on the graph, and I'm just approximating that value. Now, once again, we go back and we say, well, the other side of that axis of symmetry is just, the axis of symmetry is going to reflect those. And so what I'm going to do is, well, reflect them. Okay, so this one, for example, is 1 to the left of the axis of symmetry, so I'd go 1 to the right. That appears to be at 6, 2. And then this one, 2 to the left, so 2 to the right would be its reflection. That appears to be at 7, -1. And then again, 3 to the left, so 3 to the right here, that would be at 8, -6. And again, that's all I can fit on this one. Well, we're down to graphing the actual parabola. Here we go. Boom. Oh, that was decent for me. Let's try the other side then. Ugh. Sure, whatever. Okay, well, that's my parabola. It opened down just as we figured it would. Now the table right here. Let's take a look at a different way to find a table. And by the way, I did use my calculator to create that table right there, and it was probably more enjoyable than it should have been. But I'm going to make another table here. Okay, so I want my x and y's right here. This is also known as calculator method. Here's what we're going to do to use this calculator method, and I'm going to show you the button progression on this. So if you want to follow along, you can. So the first thing I'm going to do here is I'm going to push the button that's called, remember how we were making a table? I push the button on the calculator that says table. Now I push table and it says y equals. So in my table, I'm going to type in, because it's already showing y equals, so I'm going to type in negative parentheses x minus 5, close parentheses, squared, and then plus 3. This is what I'm going to type in, then I'm going to push enter. So I got that in, I push enter. Now on my screen it says start, and right now mine's saying 0. It says step, mine's saying 1 right now. And then below it says auto and ask x, and then at the bottom right it says okay. That's the okay part's all we're worried about. So where do I want to start? It doesn't matter. I'm going to go to the lowest value on my table. So I'm going to say, this is arbitrary by the way, I'm going to say x is 1. Okay, this is saying start where x is 1, and I want to go in steps of, this is asking for the scale. So see in my table over here how I went up by 1 every time? If I went up by 2s, then my steps would be by 2s. But since I'm going up by 1s, my step for me is 1. Okay, so I say 1, enter, I put a 1 there already. It says mine goes straight to auto, I push enter. It goes straight to okay, I push enter again. And on my calculator right now, it shows this. 1, -13, 2, -6, and 3, -1. Now, if those values don't seem familiar, just refer to them over here, right? We had 1, -13, 2, -6, 3, -1. And if you scroll downwards, if I go down to 4, it shows 4, 2. If I go down more, it says 5, 3, which was our vertex. And if I go down again, I would expect to see 6, 2. Boom, it says 6, 2. If I go down again, 7, -1. Down again, 8, -6. The calculator did all that work for me just like it did before, but I used the table function to do it. And now, is this a good way to find the vertex? You could say that you could, I suppose, but generally speaking, we use this way right here.
Is this just another?
Yeah, so I like this calculator method stuff because even though I was using storage even for this one, so it wasn't as much typing, this is even less typing, in my opinion. So, this one says, hey, we want a vertex at 2, -5, and it has to go through the point a -10. Guess and test is a way that you could do this, but I shudder to think how long it would take to find a corresponding A value for this. So here's what we're going to do, all right? As we see in my vertex, which was given as 2, -5, we have an H and we have a K value. Okay, well that's hopefully that's simple enough. Instead of an H, I now have a value of 2, and instead of a K, I've got a value of -5. So I'm going to make that -5 there. So the rest of this, again, it's pretty static. What I'm missing then is my A value, right? So I've got my f of x. I'm going to show it as y. Hope that's okay. Now this is not what we want. It's a good start, but you can't say, well, this is your equation. You just don't have an A. No, we got to figure out what that A is because we want this written in vertex form for the function. And this is where that other ordered pair comes from. This is where this other ordered pair comes in for us. Is we have an x and we have a y value. As it turns out, in the equation that we just wrote, we have an x value and we have a y value. So I'm going to go in and replace those, the x with the x value that it gave us in the ordered pair, which was 8, and the y value that corresponds with it in that ordered pair, which was -10. This right here becomes an equation to solve for A. You see, we're only left with one variable. That's great because I can solve for that variable. So right here, if I was to do this, I'd probably use a calculator, but we're going to have to use some principles of equality too. So right here, I'd say, well, 8 minus 2 is -6. Well, that would be squared, right? So -6 times -6 is 36. I'm going to rewrite that as 36a, just so it kind of looks familiar. Then I'd say -5, and this all equals -10. And you can see now that this is just kind of a regular equation to solve. So I will.
-6.
Yeah. Agreed. It wouldn't be -6, it'd be +6. The good news for me, even though I made that mistake, is that it still comes out as 36. Thank goodness. In any case, I got to solve this, right? So I'm going to add 5 to both sides. So I now have -5 equals 36a's, because we zeroed out that -5. And then the last thing we're going to do to solve for the a is we're going to divide both sides by 36. Now I'm going to keep that as a fraction, -5/36. I don't even know what the decimal would be, but I also assume it to be pretty ugly. So I got my phantom 1a equals -5/36. So I'm going to go back to my equation, right? My vertex format, which we just found the a. We already had the h and k. Yeah, this is it. We just found the a value, so I'm just going to replace the a with -5/36. That's a little better, I guess. Yeah, this is what we were going for the whole time. Now, the good news is since we've put this into a table on the calculator, you could say, well, I'm just going to put this into the calculator. And if you said, I'm going to start with an x that's 8 on the calculator for your what was it called again? The start. If you started at 8, it would start by showing you 8 -10 as an ordered pair. It works in this function because 8 -10 needs to make this equation true, right? It's a point on the line. All points on the line will make the equation true. All right, graphing quadratic functions. So vertex formula, you can find the vertex when it's already in standard form for the quadratic. Now, the truth is you could actually just use completing the square and go from there. But you can also use the vertex formula right here. Okay, -b/2a. That is the x value. And then this is showing f of this value, meaning that once you find the x, you just plug it back into the function and then see what your corresponding y value is. That's all that's saying, okay? Because once you know your x value, yeah, it would make this true. Just got to find its corresponding y value. Don't worry that it says a is never 0, because if it was, then it's a straight line, not a parabola. So this part is really insignificant because we're dealing with quadratics, but for math nerds it is. Now again, if a is positive here, then the graph opens upwards. If it's negative, then it opens downward. We don't really care about that. We just want to know what the vertex is. All right, so here we go. Consider this quadratic. We want to find the vertex, right? So let's use the vertex. So the vertex can be found just by, well, first I would solve for the x value. Now this one, it's not showing a b value for us, but there is a b value there. This could be rewritten as 9x squared, and you can keep your minus 49 there, but the middle term here would be a plus 0x. Okay, so again, this is just to have an a and a b value. So if I wanted, because I do want to find the x value, the x will be negative b over 2 times whatever the a value is. Okay, so the b we see is that 0. And then the a value showing as 9. I think some of you realize that the 9 isn't going to be significant here because 0 divided by anything is 0. Which means that in my ordered pair for my vertex, I just found that my x value is 0, right, for my vertex. Well, if x is 0, then I go back to the equation here. This is solving for the corresponding y value. So I take my equation, which is f of x equals 9x squared minus 49, and I simply replace the x with 0. And this would tell us that f of x, which is really just y, equals 9 times 0 squared minus 49 is going to be just negative 49. So I get a vertex of 0, negative 49. So that's my vertex. We just found it. I'll box it in. Next, it says, so we did find the vertex. The x value, though, the x value of its largest x-intercept is x equals something. Okay, so the x-intercept, what do we know about the x-intercept? Well, at the x-intercept, the y is 0, okay? So this means that if you were to take the equation, let's take the original equation, and this should hopefully look familiar, but then we get a 0 equals 9x squared minus 49. So to solve this one, it looks like a difference of squares, and well, it is, because 9x squared would be the same as taking 3x squared, and 49 is, 7 squared. So this is a difference of squares situation, and I'm specifically taking the shortcut to just save us a little bit of time. But this then becomes, remember it's always minus and plus, just the two bases there. So I got 3x and 7. So to find the x-intercepts, we just solve these for x. Okay, so let's solve those. I guess I'll do purple. So this 3x minus 7, if I could get that to equal 0, that would be true. So add 7. Sorry, it's kind of small there, but hopefully it makes sense. So we got 3x equals 7, and then divide both sides by 3, and I get a corresponding x value that is 7/3. Okay, so one of my ordered pairs for the x-intercept would be 7/3, 0. Let's solve for the other one, though. Okay, so again, if I could get 3x plus 7 to equal 0, then it would be true. So minus 7 from both sides. Now I get 3x equals negative 7, and then divide both sides by 3. Tells us that x could be negative 7/3. So again, as an ordered pair, the other x-intercept would be negative 7/3, 0. It asked specifically, though, for the largest. And while they look the same, one's positive, one's negative, positives are always larger than negatives. So this would be the one that's largest. The value of the y-intercept, this one came equipped with the y-intercept as the vertex right there. So the value of the y-intercept, we already know it. It was just at the vertex. Now, some students are like, well, how did you know this was at the vertex is the y-intercept? Because the x is 0. Once we know that the x was 0, this was also the y-intercept, and so the vertex just happens to be the y-intercept on this one as well. Will that happen always? Probably not, but it could. Okay, so we just made this one up. Let's see how this goes. And the vertex should be done pretty much the same way, so let's see that vertex formula. So the first thing I would want on this is my x value for my vertex, because this is a vertex. And to solve it, we see that the x value is negative b over 2 times a. Well, in this problem, I have a b value here that's negative 9, and I have an a value that's 16. So the b I replace with negative 9, and the a I replace with 16. This will be fractional, and that's okay. But let's see what this shows in my calculator. So 9 over 32. Oh crap, I was in the wrong mode. That appears like it will not be simplified, so it's just 9 over 32. Now that's my x value there for my vertex. What I then need is my y value. So I'm just going to use my calculator. Again, I'm just replacing these x's with 9 over 32. So I'm actually going to store that in for x right there. But I got 16x squared minus 9x plus 25, enter. Ooh, it's a pretty ugly, oh, it's way ugly. When I put that 932 in the calculator, it gives me 1,519/64. It's possible, it's just possible that the decimals may be handy here. So 9 divided by 32, I'm going to round these to the nearest hundredth. I got 0.28. And then the other one, the 1,519 over 64. Let's change that into a decimal. I got 23.7. Rounded.
Sorry, how you got that number?
All right, now we do have the vertex, which is great. It's great news. In fact, let's box it in because it's so great. Okay, so we do have the vertex. It says the x value, the largest x-intercept is x equals something. I'm assuming right now that this cannot be factored. Now, whether it can or not doesn't matter, because I can just use the quadratic formula to find my x-intercepts. And that would be great, because then I don't have to worry about factoring. Maybe you do want to worry about factoring. You could see if you wanted to. I'm just not going to do it. So I'm going to use my quadratic formula here. I'm just going to do it once, though. So we got all this stuff. Remember, b squared minus 4ac. Now in the problem, we see that our a value is 16, so that'd be 4 times a times c. Oh, I forgot my 2 on the bottom, right? So that'd be 2 times 16. And then my b value is 9, negative 9. So it's a negative 9, but remember the b to start out there was negative 9. And then we got a b squared in there, so that's a negative 9 squared. And then my corresponding c value there is the 25, that constant, right? So c here is 25. So it's in the discriminant, b squared minus 4ac, so I now know my c is 25. This is looking like it's going to be, I put 22, should be 25. This appears like it will be imaginary to me. Let's find out for sure. So a little bit of evaluation here because I'm worried that it will. I'm just going to worry about the discriminant. Yeah, my discriminant is negative. So here's what this means as well. I still got plus or minus, and that's good. This would have just ended up being, let's evaluate some of this. So we got 9, and then it would have been the square root. The discriminant that I got was negative 1,519. And then the denominator, 2 times 16, that's 32. What this means is that that negative is going to have to come out as an imaginary number. what does this mean? It means that there are no x-intercepts. So in this one, just because we made this one up, we didn't know that was going to happen until we did it, but there are no x-intercepts. Yeah, if you were to graph this equation, that means that the parabola does not go through the x-axis. So there are no x-intercepts except in our imagination. Or in some math nerd's imagination somewhere, some different dimension. I feel like there's a Dragon Ball Z reference in there, but I'll skip it. Okay, now the y value of the y-intercept, that's not bad, because for all of our y-intercepts, we know that the x value is 0. So really all we're going to do is replace all the x's here in the original function with 0. And so 16 times 0 and minus 9 times 0, that's all zeros. And we're just really left with that 25 right there. So this is my y-intercept. And, well, that's as much as we need, I believe. This one's my y-intercept. So this one came out with no x-intercept because we made this one up. But if you had found that this discriminant was positive, you may have irrational values, and that's okay. Remember, you would look for the positive one, though, because hopefully this number is positive, but you'd have something plus something else divided by something is going to give you positive. Usually if you subtract it, give you something smaller. Yeah. Unless maybe these values are negative for some reason. But either way, that's the way this one came out, just no x-intercepts. So we can't say one's bigger than the other.